Hi friends, so this part is miscellaneous, okay. The name miscellaneous, again I keep it in each of my video for the things which are specifically related to JEE directly. Here we are going to learn some new tricks, new questions based on whatever things have been appeared in the JEE. Plus we will be moreover concerned about the concept, not concepts I would say, tricks, new tricks we will be learning in this part, and again the questions will be discussed in the next part after this. So here we will learn just the concepts, 3, 4, 5 concepts which are not appearing as concepts but as tricks. Let's begin and discover the tricks. Let's look at some of the things which are very important for JEE, okay, advanced especially, okay. Till now whatever parametric and the rules which we have done, they were quite necessary for your board level plus the JEE mains level, okay. But now whatever we are going to discuss, that will be the actual thing which is gonna come in the JEE advanced, okay. Questions from that also will come, but they will be obviously intermixing the complex concepts which we will discuss right now, okay. As I have discussed earlier that we will be covering more standard derivatives, okay. So inverse functions and their derivatives, okay. So I've already talked about that this sign again represents d by dx, okay. So no confusions in that. So again you have to memorize. Again, if you don't believe me, then you can just have a proof of this, okay, using the fundamental, or for this what you can do, you can let this as y, sin y is equal to x. Now you can differentiate with respect to x, okay. So you will get cos y dy by dx equal to 1, okay. So dy by dx is equal to 1 by cos y. Now if sin y is x, obviously cos y you can write it as 1 over root under 1 minus x square, okay. So clearly, and again these domains you can just see that these are important because of their range, the input, okay, for the inverse functions, okay. These are in accordance with that only, whatever the domain and range. So you can memorize for these 6, again add them to the list of your formulas. I have also told about e raised to power x. So we have discussed trigonometric functions, okay, we have discussed exponents, we have discussed logarithmic differentiation, okay. We have this again is very important for boards plus JEE mains. This is a very important for both of them, okay. So and then we have discussed rational functions also in the form of quotient rule, okay. So this was inverse trigonometric, okay. For mod function, okay, what we need to do is we always need to open up the function first. Like there will be 2 derivatives. For example, if I am talking mod x minus 1, so what I will be doing, I will be writing it as minus x plus 1 and x minus 1 in their suitable ranges, okay, when x is less than minus 1, when x is greater than 1, sorry, okay. So now you will derivate it, it will be minus 1, it will be plus 1, okay. So obviously these kind of things like you did in the continuity part, you must have discussed that thing also. So LHS, in this we say left hand derivative, right hand derivative, so clearly they are not equal. So for modulus function we always have to confirm on the point of support or pivot point at which the graph is changing, okay. So there can be 2-3 modulus functions together, so for that we need to open up the brackets and then check for the differentiability. And differentiability again in case of modulus function, on the left hand side, on the right hand side it should be equal. Within that interval it's fine. Within that, like for here it is derivable after x is less than or before x is less than 1, and it's derivable after x is greater than 1, but at x equal to 1 this is the case. Left hand side and right hand side is not equal, so not differentiable, okay. So mod function again is there, then exponent is covered, okay. Quadratic and all those comes under the polynomials, okay. So those have been covered. So differentiation for most of them has been covered. Now their applicability, like when the function in function or parametric form, that kind of things are gonna be mixed, okay. Let us look at the next concept. Okay. Differentiating a function with respect to another function. This is same as the parametric form, okay, with a different name. Now I'm saying differentiate sine x with respect to maybe log x, okay. So what I can do, I know that this is okay, t equal to this, or maybe x, I can take any parameter t and q equal to this. What I can do, I can measure this t with respect to x, I can measure this q with respect to this x, and then I can do the same thing, okay. So in this, what we have to do, differentiate fx with respect to dx. So if this is this thing, then we have to find basically dy by dt, okay. So we will first find differentiation of this with respect to x, and then with respect to x. So that we can equate, okay. So this is an example here which we can use. So let me clear up the things first. So it says differentiate sine square x with respect to log x whole square, okay. So the key concept here will be, again I will say that y is equal to sine square x, yes, and maybe some other function t as log x whole square. Now if I can measure the change with respect measure the change of this, I can compare both of them, which will ultimately give me basically what I want to know. I want to have differentiate sine square x, which I'm saying is y actually. So I want to see the change of y with respect to t. So I know that y is also a function of x. This is just, I would say, inverse of saying that thing. Like one earlier we said that it's expressed in parametric form. Now we are saying differentiate with respect to another function. That is just the inverse of saying the parametric form, okay. So you just find dy by dx, find dt by dx, and then find dy by dt. So for this is 2 sin x and cos x, that is sin 2x, and this will be 2 log x by x. Okay, now the rules must have been on the tips, okay, fingertips. If they are not, make the chart again, revise it, and if necessary, prove all the things once, so that it fits right here, okay. So just divide these two, you will get dy by dt, okay. Now coming to the next concept, very two important concept, okay, the successive differentiation, okay. Now differentiation means change of independent variable, okay, change of dependent variable upon independent variable, or first quantity with the respect to the other quantity. Now again, how that change itself is varying with respect to x, that we will say double differentiation. If we are making it again, we are finding it triple, and hence it is successive. It comes under successive. We will definitely do questions based on this, again very useful questions in the coming parts, okay. So this part will conclude with the theoretical part only, and L hospital rule, okay. So this both I'm going to discuss in brief right now, okay. So suppose I want to have third derivative, okay. First derivative is simple differentiation, just third derivative means finding the successive differentiation 3 times, third derivative, okay. Suppose I want to find for cos x, okay. So the first derivative for cos x will be d of dx will be minus sin x. Now when I am taking second derivative, I will find the derivative of this part basically, which will give me minus cos x. Finding the third derivative, okay, which will give me the derivative of this part, which again is sin x, okay. So as you can see, now how do I write this basically, okay. So for first derivative, we use the term y dash. For double differentiation, double dash, triple dash, this is the notation, and in this form we will write it as d4y over dx4. Now remember this this is not x raised to power 4, okay. This just represents that with respect to x, you are differentiating 4 times and differentiating y only, okay. You are not differentiating, means this is a symbolic representation, like t is following this times, it gets multiplied, and here again you will take dx, again you will take dx, so x gets accumulated. You can learn it that way, but the simple logical explanation is that you're finding the fourth derivative. This is fourth derivative of y with respect to x, so you are multiplying that basically 4 times. This is not whole, okay, remember, this is dx4 and dx4 is different. This is not equal, okay, at all. This is means you are first making that small element and then you are making it 4 times. This means you are taking the element to the fourth power, okay, fourth time you are taking it differentiable, okay. For L'Hospital rule, it is very simple rule for calculating, evaluating the limits. What it says, limit whatever tends to this, if this is an indeterminate form, okay, indeterminate form, then you will have here this kind of thing, f dash x over g dash x, limit same. So the basically what this rule actually signifies is that if I am comparing two functions, like limit I am evaluating, the same change will be the instantaneous rate of change at the respective functions, okay. If I am saying this is one function and this is another function, so if I am calculating this function over this function at a particular value, their slopes, the ratio of their slopes will also be the same, which is justified by this rule, okay. So we'll continue with this thing, successive differentiation, okay. You will see a lot of questions based on this in the chapter test also. Chapter test video, if you might have seen or you will be seeing a lot of questions based on this in video solutions also. Plus we will be doing in the coming parts related to this, and also in JEE Advanced, a lot of questions might appear from this discussion which we have done now. You might be seeing the concepts are very easy. It will be more justified once we see the questions. Then it will be more justified, and you will see that yeah, there is a logic in saying that why these concepts come in IIT-JEE. So this concludes our whole journey as concepts, and we learned different things, but the next two parts, which are as equally important as these 7 parts are, because we are going to discuss a lot of questions in the coming parts, and the things which we have learned today, based on that we will see questions in the next part. So stay tuned for that part.